Now let's just see the next question. Question number 2 says that if two equal chords of a circle intersect within the circle, then prove that the line joining the point of intersection to the center makes equal angle with the chords. So as per the question, what we have to prove over here, let us suppose if I'll draw a circle. First of all, let us suppose this is nothing but the circle having the center at nothing but a particular point O, let us suppose, and as per the question, we have the two equal chords over here that are intersecting within the circle. Means we have the intersection of the two circles within, intersection of two chords within a circle. So let us suppose if I'm just taking this as this, so if I'm just taking this chord as nothing but AB, I'm taking this as a CD, and this is nothing but the point of intersection which I'm taking it as nothing but M, let us suppose, if I'm taking it as M, let us suppose. So further it says that we have to prove that the line joining the point of intersection to the center, means this is the line which is joining the point of intersection with the center. It makes equal angle with the chord. What does it mean? It means we have to prove that this angle is actually equal to this angle. We have to prove this thing. So for that, again we have to draw the perpendiculars over here. So let us suppose if I'm joining or I'm making the perpendiculars of this AB chord from the center as nothing but this. Let us suppose this is my first perpendicular that I'm drawing up, and this is nothing but the second perpendicular that I'm taking, and I'm calling it as nothing but N, and I'm taking it as nothing but P. Let us suppose if I'm taking it as P. So let's just start with the given conditions over here. So the given was like a circle with two equal chords, a circle with two equal chords intersecting at M, say. So what is the construction that we have taken over here? Draw ON perpendicular to AB and OP perpendicular to CD and join OM. So let's just talk about to prove what we have to prove over here. We have to prove that the angle OMN is actually equal to the angle OMP. So let's just start the proof of this one. So first of all, as you can see over here, we have the very first thing over here is nothing but we are just taking these two triangles, and if we're able to prove these two triangles being congruent to each other, then we are done with it. So let us suppose if I'm starting with the triangle, in triangle OMN and triangle OMP. First of all, as you can see, OM is nothing but is equal to OM. OM is nothing but is equal to OM. Why so? Because it is nothing but a common side to both. It is nothing but a common side. Furthermore, we know that ON is also is equal to OP. Why so? Because the distance of, or we can say that when two chords are equal to each other, then they are always equidistant from the center. So this is nothing but the theorem that two equal chords are always equidistant from the center of the circle. From the center. So using this concept, we can say that OM is nothing but is equal to OP. Furthermore, we know that the angle ONM is equal to the angle OPM. Why so? Because each is 90 degrees. So using these three things, we can say that the triangle OMN is congruent to the triangle OMP by RHS congruence criteria. By RHS, we can say that the two triangles are actually congruent to each other, and if they are congruent to each other, then by CPCT we can say that the two angles are actually equal to each other, and this is exactly what we have to prove over here. So this is nothing but the proof of this particular question. So this is what we exactly have to prove over here.